We need to differentiate between connecting in series and connecting in parallel. When you connect in series, all the current has to flow through all the components. It has no choices whatsoever. The positive side is connected to the negative side of the other components, and the current flows right the way through. If a bulb stops working, so in other words, if that stops working, then the whole thing will not work any longer if they are in series, because you've actually broken the circuit. The circuit is now, for all intents and purposes, got an open switch in it. If the light bulbs are added in series, it becomes more and more difficult. I kind of liken it to doing hurdles. I have to hurdle 1, I have to hurdle 2. If I put another one in there, I have to hurdle 3. I'm just going to get more and more tired as I add these in series, because you have no choice but to go through them all the time. So the current strength is going to decrease because these poor little electrons get more and more tired. Virtually nothing is connected in series any longer. I don't think you can get an electrical compliance certificate if anything is connected in series, because of the fact that it doesn't work if one thing stops working. So, but in the old days, they used to connect cheap Christmas tree lights in series. Maybe cheap Chinese ones still are connected like that, but most Christmas tree lights now are connected in parallel. You are asked to conduct this experiment to investigate the current strength at different points. So what you're going to do is you should have set up a simple circuit with a cell and a bulb, put the ammeter in at point 1, the ammeter in at point 2, and what you find is that the ammeter readings should be exactly the same at all points of a series circuit. It doesn't matter where I connect that ammeter. Remember, I gave you that analogy of the bicycle chain. The whole bicycle chain has to move at exactly the same rate. This is a simple circuit with main branches only. So the current strength at all points of a series circuit is constant or the same. And that's an important thing to remember. I love asking it in multiple choice questions. If we connect in parallel, things are a bit different. Either the electrons can go there or they can go there. When cells were in series, the electrons would go through the first cell, get all the energy from the first cell, and get the energy from the second one. In parallel, that doesn't happen. They get energy from either the top cell or the bottom cell, not both. So if this is, for let's say it's 1,5 volts and 1,5 volts, by the time they come out from having gone past there, it's still only 1,5 volts. What's the advantage of connecting parallel cells? And that is that they will last longer because the energy depletes at half the rate of series cells. Notice the current has a choice as to what it does, and we connect all the positives to one point and all the negatives to one point. So cells in parallel act as one cell. Fewer electrons come past for energy, so they last longer. They lose their energy more slowly. Bulbs in parallel, the good news is, when I get rid of that bulb, this bulb can continue to work. What happens if I add another light bulb to a system in parallel? I've actually made the path wider. By making it wider, I've made it easier. So adding resistors in parallel actually makes it easier. This is very important. I love asking this as well. If light bulbs are added in parallel to a parallel arrangement, the resistance of the circuit actually decreases. It's counterintuitive, but it does, and the main branch current strength will actually increase. So it actually serves to connect in parallel. The lights in your house are connected in parallel. You just need to know some names. The part of the circuit which is in series is called the main branch. The current has no choice. The minute you go into choice areas, so over here there was a choice and over here there's a choice, either to go that way or that way, and here it comes in from that side and over there. Okay, oh, this is not really right. These are electron flows. But the point is that the current has choices at those 2 points. This is called a parallel network, and that is your side branches. This is the main branch. If I were to put an ammeter on the main branch and it read 3 amps, one on this main branch would also read 3 amps. The current strength is the same at all points of the series circuit. So just a little comparison between series and parallel. Series, all the current has to flow through all the components. The current is equal in all of the components. The resistance increases as you add more, whilst in parallel the resistance decreases as you add more side branches because it gets wider. This is as if the resistor is getting longer. This is as if the resistor is getting wider. If one component fails, nothing works. If one component fails in parallel, things all start to work except for that one component. Components are connected positive to negative, whilst all the positive ends are together and all the negative ends are together. This is also worth knowing that if you've got a difficult branch, less current will go there. You've got an easy branch, less resistance, it'll get more current. So if I'm looking over here I'm going from positive to negative. I've got two choices over here, three choices actually. Can either go that way or that way or that way, and therefore my current strength on the main branch is going to be 2 plus 4 plus 1, so it's going to be 7 amps. Which bulb will shine the brightest? Well, this one over here has got 7 amps flowing through it, so it will shine most brightly. Which one is going to be the dimmest? The one with the least current flowing through it, so bulb number 4. Which one has the lowest resistance? In other words, the easiest to get through? Number 3, because the most current is going through number 3. And how much current flows through bulb 2? It's been given to you 2 amps, and they've asked what is the reading on ammeter 1. How much current flows through bulb 1? 7 amps, the same as the main branch of the circuit. That's main branch, and side branch. If you were to do an experiment where you set up 2 light bulbs in series and some cells in series as well, and you then took a voltmeter and connected between A and B, B and C, E and D, what would you get as readings? You would find the following. That if, I'm just going to take some random values, A to B read 3 volts, B to C read 4 volts, A to C would read 7 volts, and E to D would also read 7 volts. And the reason for that is if I take my colors, notice I'm between blue and green, whether I'm between E and D or A and C. So it turns out that the readings between A and B are equal to the ones between B and C, and A and C is those two added together, and D and E is the same as A and C. What do you notice if you add the readings between A and B and C? They come out as the same as A and C. What does the reading between D and E represent? The potential difference of the cells and all the potential difference in the external circuit. And the voltmeter measures what? Potential difference. The voltmeter is connected in parallel, and the sum of the two voltages across components is equal to the total voltage across the components.